Hi everyone. So today we're going to talk about how to create our first program within Tinkercad. And that program is going to be blinking an onboard LED. So the very first thing we have to do here is take our board and put it on the field. So over here, I have all of my components that I can use. I'm going to scroll down and here's my Arduino circuit board. So I'm just going to click it. And then it will let me drop it anywhere on the screen here. So I'm just going to click to drop. And this is actually the only component that we need for this program. So let's talk about some of the things on this board. Right here, we have our power source. So we can see a USB cable coming in. On the top here, all of these different little things where these red squares are showing up, these are pins where you can plug things into. And notice I have some down here as well. Right now, we're just going to be working with these numbered pins. And then in our next lesson, we'll talk about what this pin is here, the ground. So this right here, labeled with an L, is our onboard LED. So we can make this light turn on, turn off, we can make it blink. And so the goal of this task is to make it blink. Now, when you actually write the code, up here, there's a little button that says code. I'm going to click that. And notice this isn't probably what you were expecting to see. This is Scratch or drag and drop programming, but this actually isn't what we are working with. We are working with writing lines of code. So if I click this drop down under blocks, I can get blocks in text or just text, and we want to click on text. We want to continue. And here is the code we will be working with. So I'm going to walk through what each of these things mean because they actually have everything set up for us already. So our void setup is where we set up our pins. This is where we tell the code what our pins are. And so our first command is pin mode. And pin mode is a command where you can say, I want this pin to be an input or an output. Input means that you are collecting data and bringing it into the board. Output means that you are sending something out to this component. So if we have a light that we want to turn on, we want to send power out to that light, and so we want it to be an output. And now notice they have the number 13 here. So pin mode 13 output. 13 is the pin number. So if I look here, here's 13. And that happens to be the pin that this light is connected to. So we're saying that this light, pin 13, is an output. We want to send power to it. We put this in void setup because this is universal. So this works for all of our program. Void loop, on the other hand, is the program or the commands that you want the program to repeat over and over and over again. So our first command that we have here is digital write. Digital write means you are writing some sort of command to a digital pin, which is these guys here. Now, these ones with the little squigglies in them here, these are called analog pins. They can be analog or digital. Don't worry about analog pins right now. We're not going to talk about those quite yet. So we want digital write 13 because that's the pin we're working with that our light's connected to. And then we write comma and then high. High simply means on and low means off. So the thing about a digital pin is that it can only be on or off. There is no in between. You can't dim the light at all with a digital pin. It's either on or off. And then we have a delay. A delay simply means wait. And we have a 1000, and that's milliseconds. So we're waiting 1000 milliseconds. We have digital write 13 low, so we're turning it off and waiting 1000 seconds. Now to see what this looks like when you run it, you can click Start Simulation. And notice this light starts to blink. I'm going to stop simulation. Now, why do we need this delay in here, this delay 1000? What happens if I were to take it out and then start simulation? Well, it looks like the light just came on, but why isn't it blinking? Here's the thing, it actually is blinking, but it's happening so fast that your eyes can't pick it up. And so that's why we need the delay. And this time let's try 500. And when you write lines of code, everything in C++, this coding language, every line must end with a semicolon. If it doesn't, your code won't work. Let's try delay 500. And now let's try this start simulation. Now it's blinking faster. And I can change any of these numbers to make it blink faster or slower. If I wanted to stay on for 1.5 seconds, I can do delay 1500. Oops, I have to stop the simulation first. 1500, and then start it again. Now notice it's on for a lot longer than it's off, so you can play with these and make it blink multiple times. You can even write more lines of code. So if I wanted to blink on for 1.5 seconds, off for 0.5 seconds, and then back on for another second, I can simply write digital write 13, comma, high, which is on. That's turning it on, and now I need my delay. And let's say I wanted to delay for 1 second or 1,000 milliseconds. And now I have to turn it off again to make it blink. So another digital write. And let's do 500, whoops, sorry. I need 13. Low, which is off. And I need one more delay. So let's do a delay 1000. And now I can start simulation. So you see we have 2 different blinking patterns here, and you can play with this. I've had kids play with this and make the light blink to the beat of a song, which is kind of interesting. One other thing I want to add is when you turn in an assignment, I'm going to want you to put in comments telling you what each line does. So if I click here and I write slash, oops, stop simulation. If I write slash slash, see it turns orange, and I can start writing comments. So this would be turn onboard LED on. These don't impact your code at all, but it lets you know what this line of code does. So every time you turn in an assignment, each line will need comments telling me what it does. Okay, the last thing I want to talk about is something called a global variable. So let's say you have this big, long code, you've repeated stuff like this dozens of times, but suddenly we're changing something. Let's say we want to put in a separate LED circuit, we're hooking it up to a different pin number. That would mean you'd have to go through and change all of these numbers individually in your code. Well, that's kind of a pain in the butt. So instead we can set up global variables, and that actually goes above void setup. So we want to write int, which means integer. And then let's call this LED equal, oops, space equals 13. This is telling us that whenever we put in the letters LED, it means pin 13. So I can actually go through here and change everywhere I have pin 13 to LED. Okay, and now let's start simulation again. Let's see here. So here we have an error. And this is actually a good thing because I want you to look at this. So it says error expected, comma or semicolon before void. So it highlights the line where it thinks something is going wrong. Remember when I said each line of code you write has to end with a semicolon? Well, up here I forgot my semicolon. So if I put that in now, and now try to start the simulation, now my simulation is running. And so let's say we did have to alter this code somehow, and we set up a different LED that was actually plugged into, let's say, pin 9. Instead of now going through and changing all of these numbers in here, I can just go up to my global variable, erase the number 13, and put in a number 9, and it automatically changes everything for this code here. So it's not really necessary right now that we use a global variable because our program is really short. But once we get into very long programs, doing a global variable is a lot nicer and a lot easier to edit. Okay, so I want you to play around with this. Play around with making the light blink different ways. Your assignment is linked in on Classroom, so under Lesson 1, it tells you what exactly you have to accomplish. And please don't forget to put in comments after every line. You are not required to have a global variable, but you can try it if you want and play with it a little bit. If you have any questions, out on Classroom here, oops, wrong class. Under additional Arduino resources, I linked in a website called toptechboy.com. This guy has Arduino lessons, and I'm kind of following his format here. So we are under his lesson 1 right now, and he takes you through all the different commands and all the different parts of the board. So if you want additional help, you can watch his videos and look at what he has as well. If you have any questions, please let me know. If you don't remember how to submit an assignment on Classroom with this, go back and watch the introductory Tinkercad video. All right, have fun tinkering.